tiny gold tab on this chip is a sign of hidden value. Is it actually worth the work to extract it? Today I'm processing a sample of these gold corner BGA chips to see if a bulk purchase would make sense or if I'm just chasing pennies. These chips have up to 3 distinct parts. You've got the heat sink, the plastic epoxy top, and the green fiberboard base. Now the base looks like it's full of gold, but the actual volume is minuscule. To get the real values, we're going to focus strictly on the black tops. But first we're going to weigh it up. I was offered a big lot of these, but I've never really worked with them and I don't like mine blind, so I asked for a small sample to test before I would buy. After stripping the boards of our 250 gram sample, we can see there's 133 grams of bottom pieces, and our total sample is 258 grams. This leaves us 125 grams of the black epoxy where the gold is to work with. Time to see what's actually inside them. First step, pyrolysis. We're going to burn off the volatiles in the epoxies within this furnace. The furnace does a great job. No smoke, just heat. You can see the chips are already brittle and ashed white on the outside. Once cool, I'm going to hit them on the burner to release any of the internal copper heat sinks that might still be attached. Those would wreck my grinder, so they got to be removed the hard way. The other thing you can see while I'm doing this is even though the chips are ashed white on the outside, as they break up a little bit, there's plenty of black carbon in these chips left that didn't get exposed to air. After we grind, we're going to have to take care of that. So we're done, everything's cooled. I'm going to go ahead and pull these copper heat sinks out. They don't have any gold value. This causes problems later. Finally, to get our chip material into the grinder, I'm going to transfer everything to this gold pan just to make it easier to pour into the smaller opening of the grinder. Now we grind. I put the chip material in the grinder. Only takes a couple of minutes of grinding and we'll have nice fine powder that will ensure we've liberated all those 24 karat gold bond wires. This creates a lot of dust too. Very important to be wearing a dust mask while doing this. You don't really want this stuff in your lungs. Going to go ahead and get our powder back into the pan. All those little black pieces in those chips are still carbon. So we're going to take this powder and we're going to go back over to the burner and we're going to re-incinerate this until we have a nice fine, almost white material. One of the important things with this is to stir it around. In order to truly get rid of the carbon, it needs to be exposed to oxygen, which will then convert it to carbon dioxide. All right, this is our ash powder. I'm wetting it down slowly so it doesn't poof on me. It's very dry. If I had a lot more of this, I'd have to do some separation to get the metals and heavies out of the ash, but this is so little, I'm going to go ahead and just process it all. Okay, a little more distilled water. I'm going to set it up on the heat, and we're going to add about 50 milliliters of nitric acid to dissolve any base metals that are mixed in that ash. And then we're going to go ahead and start recovering our gold. So our nitric boil is complete. Pull this off the heat and let it cool for a little bit. Once it's cool, I'm going to go ahead and filter it out. This filter, we're looking to get all the spent nitric out of what's left of the mud. The mud contains leftover ash as well as our values. To do this, I'm going to set the filter up with the filter paper folded up like a coffee filter. This will contain all of our mud as we go through the process. All right, everything's gone through. There's our mud. We can see, however, in the beaker that we've got some solids that came through the initial filtration. So we're going to run this all back through one more time because those solids may contain values. What we're looking for is a nice, clear, spent nitric solution. It may have silver in it, so we're going to set that aside and check it later. Right now, we're just after the gold. Okay, this time we have a nice clear solution. There's our mud. We've rinsed it several times with distilled water as well. Set this aside, and we're going to take our mud now, filter and all, and that's where our gold is. We're going to put this into a smaller beaker, add hydrochloric acid, forming Aqua Regia. Go ahead and get that all down in there. We're going to put it up on the heat. We're going to add just a little bit of sulfuric acid. This will drop any lead if we don't need to add sulfamic acid later. And then we're going to add about 6 milliliters of nitric acid to dissolve our gold in Aqua Regia. This is a small sample. This is probably way too much even for what's here, but with this mud like this, we want to make sure we get enough for it to get really into it and find all the little bits of gold that are there. Turn on the heat and let it do its thing. Because we added probably too much nitric, while the solution is still hot, I'm going to add some sulfamic acid a little at a time. This will kill off any excess nitric. We keep doing this until we stop seeing a reaction as we put extra in there. A quick little stir. I think we're good. So we'll rinse this down. We're going to pull it off the heat and let it cool. All right, our solution is cooled. So now we're going to filter it up. First, we're going to do a quick test to make sure we actually have gold in solution. And we do. Lots of interesting colors there, so my guess is there's some other stuff in solution as well. Well, let's get ready to filter it. Again, I'm using a filter folded like a coffee filter. It's because we still have the excess mud. The goal here is to separate the gold-bearing solution from the mud. This first filtration is really just focused on getting those into 2 different states where we can then manage to get our solution clear without having to deal with that mud every time. Once the solution is through the filter, we're going to rinse several times with distilled water to get all of the gold-bearing solution out of the mud and into the beaker. There's what's left of our mud. We're going to set that aside. We're going to go ahead and you can see that this is not clear solution at all. We're going to refilter this, but we're going to start with a new filter paper so that we don't have to deal with going through that mud every single time until we get a crystal clear solution. First time through, looking better, but still a little cloudy, so we're going to go through one more time. Right, this time things are looking much better. You can see all that junk that we took out of that solution. Our solution is very clear this time. You can see my fingers through the beaker there, or the flask, really nicely. So we're going to go ahead and get this transferred into our beaker. To do our precipitation, we're going to use sodium metabisulfite. This is stump out bibonide, which is primarily that chemical. And we're going to go ahead and drop our gold. Get us add a little bit at a time. We should see a color change come here. See it just a little bit going. We're going to add a little bit more. And we'll go ahead and do now a stannous chloride test to see if we've got all of our gold out of solution. This is showing just a little bit of color, so we're going to add just a bit more SMB. Test one more time. This time we've got no result, so we're going to cover this up and let our gold settle. As the gold is settling on just low heat here, you can see that color left in the leftover solution. There's definitely other materials in there, most likely some kind of iron. So we're going to drain that off. Going to move our gold into a smaller beaker. We're going to wash it several times with distilled water. It really probably could use another repurification or re-refining, but it's so little, I'm not going to worry about that at this point. I'm just going to clean it up with distilled water, melt it out, get a yield so I can get some idea of how much gold is really in these chips. So there's our little bit of relatively dirty gold powder. Let's get it melted, see what we got. Pull our little metal bead out of here and quench it. There we have it. Not particularly clean, but it's gold. I'm going to say probably between 90 and 95% pure. So here we have our button. Let's see what we get from it. You see it's not particularly pure, but from that 250 grams of chips, we have 0.66 grams of gold here. I'm going to call it a conservative 0.6 grams of actual pure gold. That's going to be roughly about 2.4 grams of pure gold per full kilo of this particular set of chips, which is what I need to know to make a fair offer on that bulk lot. All right, well, that wraps up this test in this video. If you enjoyed the refining, hit that subscribe button and give this video a like. More refining experiments are on the way. Have a question or comment about BGAs or refining in general? Drop in the comments below, and thanks for watching.